Okay, welcome everybody. Okay, so today we'll continue learning some basic Python programming, and as usual we'll use Anaconda, Jupyter packages in Anaconda, and of course we'll do Python version 3.5. Okay, I'm going to launch Jupyter now. Okay, here is Jupyter, and I'll open now a Python notebook. I'll go to new, and this is where it is. Okay, so now we can start programming in this cell. By the way, can everybody read what is written here, or is it too small? Too small? Yes. Okay. How about now? Okay, now should be better, right? All right, so here is how we will learn Python today. First, I will describe some problem which has nothing to do with programming. First, I'll describe some problem which we need to solve, and then we will solve that problem using Python, okay? First, I'll describe you some program, and then we'll use Python in order to solve that program. Okay, we start. The first example is extremely simple, but subsequent examples will be more and more complicated and advanced. Okay, what we start with is something completely trivial, okay? Completely trivial. Let's assume that we have three-dimensional vector in three-dimensional space. You know, it's components in each of these dimensions. This is given, and we need to calculate its magnitude. Okay, that's all we want to do in the first example. When we launch this program, we want it to be operate in the following way. When we launch it, we want this program to ask you, the person who is using it, the person who is launching it, to enter the values of components, x, y, z components. Okay, suppose you want to calculate magnitude of a vector in x, y, z components. Okay, let's do that. Let's do that example. Okay, so the first thing we need to do then is to ask the user of that program to enter those components. How can we do that? We can do that through a built-in function in Python called input. Okay, so here is how I will say. So it's x component. I will call it x component of the vector, x equal to input, and this is how I will do it. Input, enter x component. This is the text to explain to the user what that user needs to enter. Okay, so let's see how it operates. Okay, let's see how this line works. This very simple line. Okay, I'm going to launch it. When I launch it, I launch it right now. So this is where a program launches it, and this is where a program is running it. So can everybody see the text visible? Text is visible? Very good. Okay, so here it is asking, now I launched this program, now program is running, and program is asking the user, which is me in this case, to enter the x component of the vector. Okay, let's enter something. Let's enter 4. It runs, and this is where it stops, right? This is just one line. It is just asking us to enter that. Let's go one step further. Now, let's print out what we entered. Okay, let's make the program to print out what we entered. We just say print x. Or I can make it a little bit involved and say you entered x. First, it will say you entered, and then the print out the value of x, which we put it in first. Okay, let me run it again. Okay, I'm running it again, so it is again asking me to enter x component, just like previous time. So let me enter 6, and it says enter 6. Okay, now let me rerun it again. Let me try something different. Let me try something completely random. Let me see. And it says you entered this. Okay, I entered some random symbols, characters, and now it's printing out that. All right, so what does it mean? It means that this input, this function, built-in function input, is returning string. What it returns. So input function, whatever you enter, assumes that what you enter is of string type. So it understands some set of characters. It doesn't understand it as some value 4 or 2, but it understands as a set of characters. Okay? Now, this is a problem for us. Because we need a numerical value. Because we want ultimately to calculate the magnitude of a vector. In order to calculate the magnitude of a vector, we have to make certain operations, right? Calculate a square of components, add them, and take square root. But if this input is understanding it as characters, as some string variable, we cannot do mathematical operations. So we have to do something else here. And that something else is the following. We have to transform what input is providing to value x to something different first. We have to transfer it to floating point variable, okay? And we can achieve that using another built-in function called float. If I say float and close it with brackets, whatever is inside brackets, this function float will transform into a floating point variable, to a variable of floating point type. All right, let's try something. Okay, I'm going to enter this 1, and I can enter whatever number. First, let's start with number. If I enter 1, input then returns 1 to the system. And then this float transports or translates that character 1 into a floating point number. Okay, let's see. Let's run it. I'm going to enter 1. Let's see what happens. This is what happens. I entered character 1, and now this function float translated it to a floating point variable 1.0. And we can do operations on that number. Okay? Now, let's do the same for y component, sorry. Y component and z component. Okay? In this program now, after you enter x component, you'll have to enter y component, and you have to enter z component. After that, we can calculate the magnitude of the vector, absolute value of the vector. Okay, let's call it r. R will be equal to square root. This is what square root is, function which calculates square root. Okay, let me not use it. Let me use another function. So this is basically x square plus y square plus z square, and everything is square root, right? That's it. And let me write now. The magnitude of the vector is, okay. And let's print out the result. Okay, now we finished writing the program. Let's run it. Okay, let's run it. Okay, let's run it. Let's see what happens. Okay, first it's going through now Python is going through its first line. First line is asking us to enter x component. Let's enter x component. Let's say it is 1. Okay, let's say it's 1. Second component, let's say it's 3. And third component, let's say it's 10. Okay, and now it calculates the magnitude, and its magnitude is this value, 10.4888, and so on. Okay, we did this program. Yes?
How to control the number of points after the block?
Okay, how to control, the question is how to control the number of points here, right? Because it's printing out a lot of digits, and this sometimes we don't need that many digits, right? There are ways of controlling that inside this function print. We are not going to go through that today. It's a bit too complicated for the first lecture, okay? At some point, a bit later, I will describe, or we can discuss about it after this class. All right. Any other questions? Yes?
So R is automatically float.
R is automatically float, exactly. Because, why is that? Because these variables are already float, and then you are taking square root afterwards. And when you do that, you get float as a result.
And also, how to write after the variables?
How to write what?
I mean, after the answer. I mean, you have like this answer, and after this, yeah, after that, how to write after that?
Oh, how to write after that? You can just say this one.
Okay.
Another thing.
Okay.
Yes, this is what it is. Okay, so one thing you notice here, Python is going through it line by line. First line, second line, third line, right? It executes first line, prints out second line, executes third line, and so on and on. Okay? Program is executing line by line. It's going from first line to second line, and so on, until the last line. But this is not always the case. You can make Python to execute certain line and skip other lines. Okay? There are possibility to do that, and we are going to explore it next. Okay? In the next example. So in the next example, we solve different type of problem. Okay, very simple problem, but we'll learn how to program that. So here is what we need to solve. We need to write a program. When we launch that program asks the temperature of water. Okay, and you enter the temperature of water, and then the program tells you whether the water is in ice state, gas state, or liquid state. Okay, in usual atmospheric conditions. Okay, you enter the temperature. So if you enter -10, it has to say that it's in ice state. If you enter 5, it has to say it's in liquid state. If you enter 200, it has to say that it's in gas state. That's the program we need to make. Okay, so as you can guess, depending on what you enter, this program has to do different things. In our previous program, independent of what you are entering, it is doing the same thing. It's going line by line, and at the end, applying this formula. Now, depending on what we enter, program has to do different things. It has to say whether it's ice, liquid, or gas. Okay, let's try to do that. So again, the first thing we do, okay, let me remove this now. We don't need this. So let's start from scratch. So now what we need to do is the following. First, of course, we need to get the value of temperature. We do it in the same way. We say T is float input enter temperature. And this is where we get the temperature, right? This line will enter as the temperature. All right, now we can do this. If, this is a statement which Python understands. If temperature is larger than 100, if T is larger than 100, okay, if temperature is larger than 100, let me press enter. And when I press enter, it arrives at this point. There is some shift with respect to this initial point. And what that means is that if T is larger than 100, the next code which will be executed is the code which is located here, which is the one which is shifted horizontally with respect to this 0 position, initial position. Okay, then I say print water is in gas state. Okay, if temperature is larger than 100, then I should say only, the program should say, water is in gas state. Very good. Now, if on the other hand, if another condition is met, and we can achieve that by using elif T is larger than 0, but, and T is smaller than 100, this is how we can write these two conditions. We are now considering the case when water is liquid. In that case, temperature is larger than 0 and smaller than 100. That you can achieve through two conditions. T is larger than 0 and T is smaller than 100. There are other ways of writing this one, but this is one of the simplest ones. Okay, this is how you can combine two conditions. If T is larger than 0 and T is smaller than 100, in that case, we print water is in liquid state. Finally, the rest of the condition is that if temperature is less than 0, right? Else, okay, let me make a little change here. Here, instead of saying larger than 100, I will say larger or equal to 100. And here, let's say larger than equal to or equal to 0. Else, the rest of the condition is that T is smaller than 0, right? T is smaller than 0. In that case, we say print, we have ice. It is icy. It is ice. All right, I think we are done. We wrote this program. Now let's launch it. Okay, let me see. So let me try 5. It says water is in liquid state, which is correct. Let me try something else. I can do it like this to make it a little bit nicer. So let me launch it again. Let me try minus 56, minus 60. It is ice. And finally, let me try 100 in gas state. 105, 104. It's also in gas state. Just a side note, it's not a good idea to use this statement usually, this kind of statement for floating point variables. It will become clear later. I'm not going to go through details now, okay? But let's start here. Now it's time for questions. Yes?
Conditions of t should be less than 100.
Very good point, actually, yes. Very good point. Well, so that's a dangerous, that's very dangerous, because if you enter t is equal to 110, 110, both of these conditions are right. But the code is going through line by line. Yeah, I know. So which correspond to which case? So I'm wanting it to enter 50, right? T is equal to 50, for example. And you are saying that in this case, I should do it like this one?
Yes.
All right. Yes. Okay. All right. Okay. I see what you mean. But this is. I would say that this is not a good idea to do this one, because I don't know. Maybe it's a good idea. So what I would do here, I would try to make the code simple and readable when I'm writing a code. So that's one of the most important characteristics of a code. When you're writing a code, you want to make it simple and readable. And if someone is reading this statement, it may be easier if it is explicitly written all the limits without any ambiguity. So I'm sure you can make even elaborate statements here. I'm sure you can do like 10 or 20 different combinations. But the most important thing, especially today, is to write it in the most simple and the most easily understandable way. So explicitly writing all these commands. Yes, it totally works. And if you do 110, it should also work, right? 110. Yes, in gas state, because code is, although both of these conditions are correct now, first code reads this point and executes that and finishes at that point. Okay, you can do that. It works, but probably I wouldn't do that. Sergey, what do you think?
I totally agree with you. The readability is more important.
Yeah.
But if we change the place,
You can do 100 different combinations here.
It
It's-
will give the first one or the second one. Because
In that case, okay,
it should give
if you want to replace these two conditions, right?
if you just change.
Yes, in that case, you can do something different. In that case, it will not be correct, right? If you do 110, it will first execute. Yes, first one. In that case, it will not. But in this case, in principle, it's correct, but it's not good from the point of view of simplicity and readability. You want to make it really clear. When I look at it, I really want to understand it immediately what you want to do. And if you want to create this smart, intricate algorithms, it's not a good idea. Because when you write a code, when you write useful code, it will be read more than written. Okay? You want to make your code very readable. Okay, so we are done with this example, and I'm going to go to my next example.
Sorry.
Yes?
How can we, what would be if we enter the text?
In that case, okay. The question is, what will happen if we enter text in when it is asking to enter temperature, right? That's the question, right?
Yeah.
That was the question? Okay, that's the question. In that case, it will not work. Because, why? When you enter a text, if you write something, right? Suppose you say you write 100, okay? Actually, let's try. 100, okay, no, 100. I'm entering 100. Let's try. It's not going to work. It's an error. Why? Because when you enter 100, Python doesn't know how to transform that 100 to actual value 100. That said, you can write a very complicated code, which when you write 100, will look in the dictionary and find out what is the meaning of 100 and whether it corresponds to a value, and do this elaborate thing. Python cannot do this. Built-in function in Python cannot do that. So this is not going to work. All right, so let's move to the next example. All right, what is my next example? Okay, my next example is the following. We want to do the following. We want to solve the following problem. Okay, we want to create a program. and there is some information inside that program. There is some information inside that program which the user needs to get. So when we launch, we want this program to ask the user to enter a password, to enter the password. Okay? And the password is correct, it will give that information. If the password is incorrect, we will do something very simple. If the password is incorrect, the program should ask that password again. If it's incorrect, and again, and then again, and again, and keep asking. This is very stupid from security point of view, but it is simple from programming point of view. Since we want to learn programming, basics of programming, we start from something simple. In the second example, we'll ask the program to give the user only 3 attempts to enter password, okay? In the next example. But first, we start with something simple. Again, let me repeat. So we are going to write a program. When we launch this program will ask a password. The program itself knows what is the correct password. And it compares with what you entered with what it knows. And if it is matches, it will give us correct information. Okay? Again, in this example, depending on what you enter, the code should execute different parts. Our entire Python code should execute different parts of it. But this time, not through if, but different thing, which is called while. Okay, let's do that again. Okay, let's enter password again. Let's call it P is equal to input, enter password. Now, let's say the password itself, the correct password is Python. Okay. In this line, Python asks the user to enter the password, and this is the correct password. And now we have to check whether the password is correct or not. Okay. So I can do it through while. While t is not equal to password. Okay. So if password is not equal, if what we entered is not equal to the correct password, so what we want is to ask the user to enter again. Yes, exactly, P, not P or P. P is equal to input. We want to ask the user to enter again. Password is wrong. Enter again. All right. All right, and so what it is doing now, when P, which we enter, is not equal to the correct password, it will keep asking. It will keep executing the line between this. It will keep executing this line, and again, and again. Okay? On the other hand, if it is correct, if the password which you entered is correct, it will not execute it. It will pass through it without executing it, and it will execute next line. And next line will be here. Password, now password is correct. So we register password is correct. The information which you are looking for is here. So, okay. Okay, we did this program. And let's see how it works. Let's try it. All right, let's enter the password. Let's try something random. Okay, it says password is wrong. Enter again. Let's try to enter it again. Wrong again. Now let's try to enter the correct password. The correct password is Python. Let's try to enter it. If it is correct password, now executes this line. It doesn't execute this one, it executes this line. And so it says password is correct. And this is where we get the information which is hidden. All right, this is the simplest version. Now let's make it a little bit more complicated and a little bit smarter. So we want the user to give only 3 attempts to enter password. Okay. If the user enters more than 3 times, the program exits. Okay? We only give 3 attempts. Okay? So I'm going to introduce a variable. Let me call it, let's say, imax, maximum number of trials. Let's say this is 3. Okay? And I will count the number of, I will introduce another variable. I call it I, and this is here. And that I will count how many times I'm entering. Okay, if I enter 1 more time, I becomes 2. Okay, here I should be equal to 1 because in the first line, I already did it once, right? First line already inputted. So I should be equal to 1. Now here I'm entering it again. So I has to increase by 1 more. So I say I is equal to I plus 1 now. I increase the value by 1. Now, here I check. If I is equal to I max, then I will stop. I say break. And I can stop while loop through a command called break. Okay, this is where it exits. So again, let me repeat. This condition checks if I is equal to 3. If I try 3 times, I becomes 3, right, through this operation. And this is the point where I break. Now, let me ask you, is this a correct program now? Is it going to work correctly? No, because when I break, it goes to this point and executes this line. And this is line exactly which I want to hide, right? Because if it exits because of 3 attempts, maximum number of attempts, I don't want the computer to give the correct answer. So I have to hide it. So I have to check in this line, I need to check whether the user made 3 attempts, maximum number of attempts. I can do that through if statement. If I max, in that case, I have to execute something different. I say password is wrong. Or I will say, you entered incorrect password, IMAX times. Else. Now it is correct, right? Now what happens is that if it breaks here through this, because of this I being equal to IMAX, it will check. If that is the case, then it says you entered the password incorrectly, IMAX times, but it doesn't do this line. On the other hand, if this is not the case, it will execute that line. Let's see. I'm going to run it now. Let me try it first. Wrong. Second time, wrong. Third time, wrong. And it says you entered 3 times and exits. Now it's better. Alternatively, let's try to enter the correct password. Second time we enter. Okay. Correct password is Python. Let me try that. And it works. Okay. Okay, let's move on then. Now we are going to learn slightly different facility, slightly different capability in Python. And that capability is containing different values or different quantities using one object. Okay? In one object, we want to have different values or different quantities. Okay? We can achieve that through a thing called lists in Python. List. Okay? There are many different variety of things which have a similar goal, but we are only going to look at lists and what is known as NumPy arrays today. 2 things, okay? There are other things, but the most commonly used ones, especially in computational physics, are lists and arrays, NumPy arrays. We start with lists, okay? Then introduce NumPy arrays and discuss what are the difference. Lists. Lists, the way we initialize list is the following. Suppose we want to have a list which contain numbers. List will contain numbers, okay? I'll say numbers is equal to this. So this line will initialize empty list. A list which has no components, nothing inside. Okay, so this is how I declare empty list. So let me execute this one. Print, let's call it numbers. I'm going to run it. And it prints out. It prints out these empty brackets with nothing inside. But let's add some elements. Let's add some numbers. 3, 5, several numbers. Okay? So let's try to execute it. And this is what we get. So list contains now 5 elements. First element is 3, 6, 3, 6, 123. Okay, several elements. Different elements of the list can be of different types. Okay, they can be strings. Let's say, let's write student And let's add me a floating point number here, 1.32 E12. Let me try it again. And this is what it is. Now, the number of elements in lists can be dynamically changed. You can change it, add them or subtract them. You can remove elements or add elements. How we can do that? We can do it through this one. We say numbers, append. Append adds one more element. Let's add one more element. Let's say we want to add, what do we want to add? Let's say that we want to add a word. And let that word be table. And let me print it again now. Okay? So initially, list is given by this first line. We print that. We add one more element at the end of it, and we print it again. This is what happens. Initial list is here, but then we added one more thing, and this is what happened. Okay? There is a command which is useful, which has to do with list. That is how to calculate the number of elements within that list. And that's very simple. That's achieved through a function called len. I say print len numbers. It will print out the length of numbers. There is a list called numbers. This function will calculate how many elements are there and print out. Let's run it. It says 8. Is it 8? Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8. 8, exactly 8. All right, now using this capability of lists, we are going to solve one more problem. One more problem. So here is here's a problem. We need a software which, when we launch, will ask how many students are in the class, how many students. Then it asks you, the user, to enter GPA of each student, for example. And then the program calculates average GPA in the class. We want to do that through lists, okay, through lists. There are, of course, thousands of other ways of doing it, including intricate, impossible to read ones, but we are not going to go there. We want to use the most simple and the most educational example, okay? All right, let's go there. Okay, first thing I want is to enter the number of students. Number of students. Let's call it n. Input, enter the number of students. I used int here. Why do I use int? Why do I convert input to int? Integer number, right? Because number of students is integer. Okay, let me introduce empty list now. Let's call it GPA. Okay, this is the GPA of each student. Let me declare empty list. Now I want the user to enter GPA of each student. And I can achieve that through this example while. Okay? Let me introduce variable I to count which student I'm entering, GPA of which student I'm entering. While I is smaller than n, now I want GPA for that particular student. And I want to add that, append A. Okay? So here I'm asking the user to enter the GPA of the student with index I. And then I add that GPA. First I transfer it to float, and then add it to this list GPA. Good. And now I say I equal to I plus 1. Because I have to go to the next student and repeat this sequence again. We keep doing it until we reach the maximum number of students. All right. So average is sum GPA. Function sum GPA sums all the elements of that list. Another useful function. Divided by the length of that array, right? Now we can print it. Okay. Let's see. Let's run. Let's say there are 3 students. First student has a GPA of 1, second is 2, third is 3. Average is 2. So this is how we can achieve that. All right, I'm almost done. So we did that through list. Now I want to do that through a different capability, which is NumPy array. NumPy arrays have certain differences with respect to lists. Okay, so they do certain things better. Number one, they are faster. Okay, they are faster. And so you can execute operations, mathematical operations, much faster than you do with lists. That's one of the primary reasons why people use arrays. But in order to achieve that, arrays have one restriction, which is you cannot change the number of elements dynamically. You cannot dynamically add elements to that array. You have to specify the number of elements and the type of elements initially. All the elements should have the same type and a given number. Okay? So that is given through a NumPy arrays are located in a package called NumPy. So from that I have to import that package first. Okay, we do not need to import everything from that, but we will import only one thing, which is a function called zeros. Okay, function called zeros. Okay, what does zeros do? Zeros will declare an array of a given size and given type and assign 0 to each of those elements. We just need that function, okay? As I said, in order to use NumPy arrays, we have to declare them. We declare them through function zeros. Again, there are many other ways of declaring it, but we start with something very simple. Okay, we start from zeros. So I say from NumPy import zeros. Okay, we have to import function zeros. Now I want to declare GPA is zeros, and this is how I will declare. First, I have to enter the number of students because I have to know the length of that array, of course, right? It has to be equal to the number of students. So when I do that, now I say zeros, n, and float. Okay? N tells how many elements are there. Float tells what are the types of each of those elements. Okay, good. Now I can get rid of this line because this is declaring list. We don't need lists. We have arrays now. All right. And what I can do here, I can remove this line. Instead, I can say GPA I is equal to that. This means that element number I, okay, not exactly number, but it's related to number. I of GPA is equal to that one. Okay, and when I is equal to 0, it is pointing to the first element. Okay. So that's a peculiarity of this thing. We'll discuss in a bit. The rest will remain the same, I think. Okay, let's try to run it. Numbers 3, 1, 2, 3. And correct, we got it. Okay? The rest is very similar. Now, let me print that GPA. The one which we entered. So you see, we have 1, 2, 3, because we entered 1, 2, 3. Okay, but I want to print particular element of this one. Let's say I want to print out only first element. I don't want to print out everything. I just want to print out certain particular element. Let's start the first element, okay? I want to print out this value. How I can do that? I do it through this program. Print GPA, square brackets, 0, okay? When we say 0, it is actually means the first one. When we say 1 here, it actually means the second element, and so on. So counting starts from 0, okay? And there are good reasons why it starts from 0. Okay, let me try to run it. So, okay, if I say 0, it gives this one, the first element. Let me try something different. Let me try 2. 2 should give me the last element, this 3. Let's see if it does. It does. Now let me try 3. What's going to happen? It's an error because third element doesn't exist. We didn't declare this array to have that many elements. Okay, question time.
Can we print particular elements if we use append?
In an array?
Yes.
Yeah, so again, array you cannot use append. Append you can use only with lists. Because array, you cannot change its length after you declare it. You have to declare it, and it stays the same. In order to use different lengths, first you have to remove that array and declare it again. But with this, you can do that. Syntax will be the same, yes. If you use append, its length increases by 1, and you can do that.
How to remove element from list?
Say that louder.
How to remove element from list?
How to elements? There is a program called pop, not program function. Instead of append, you say pop. Okay. So the question is how to remove elements from list. Okay. Let's define the one function. Let's say R is 1, 4, 3, and let's add something. Okay. So here is a list. I'm answering your question. Can you please not talk while I'm not talking? So here is a list with 3 elements. And this is, let's say, is wrong, right? We want to remove it, right? It's very simple. You say R pop, it will remove the last element. And let's now print R. You see, it removed. That's how you can do it. Any other questions?
It's not lost.
Sorry?
It's not the last element.
I'm sure there are ways of removing other parts. I do not remember. Okay, which brings me to the next point, which is, in this business, there are things which you don't know. There are things which I don't know. Anyone doing computational science programming, there has tons of things which he or she doesn't know, but he, she, may need to use it. And the skilled programmer is not the one who knows all of them. Skilled programmer is the one who can find the answer quickly. And that's another skill which you have to learn. There are millions of different, in these particular examples which I taught to you, there are a million other things you can do, million other ways. I do not know all of them. But if needed, I should be able to find the answer very quickly. And nowadays, there are so many different facilities, starting from Google. Any other questions? All right, thank you, guys.